So welcome to the keynote for the second cloud-based international conference on computational systems for health and sustainability. So I'm going to give a talk on data science for IoT. You may know about data science as one entity and IoT as another one. But in this talk, I'm going to explain on how to incorporate between these two and make efficient decision-making systems in Internet of Things. So let's get started with this. So to introduce about me, I'm a faculty member and I teach data science and analytics for the Faculty of Information Technology with Chinese Institute of Technology, Bangkok. So today we are going to see an introduction about data science, and then we look into the IoT in data science, and then finally we'll have a small case study in IoT, which is a small project which I have done previously. So when you think about data science, it's like a interdisciplinary area which comprises of computer science and IT, mathematics and statistics, domain or business knowledge. So you need to be good in programming, and you need to be proficient enough in math and statistics. It doesn't mean that you need to have grill hard with your engineering mathematics or something like that. It's quite simple. Like you can start with some simple statistics and then start moving ahead with the advanced levels. So you can have some kind of confidence when you learn this math and statistics. And business or domain knowledge, you need to have the domain knowledge about it. So when you incorporate this domain knowledge with math and statistics, and then you do the programming, then it becomes data science. What data science does is it does the data analytics. Prior to data science, we do have a term called data analysis. There is a difference between data analysis and data analytics. Data analysis deals with the trend of data which happened in the past and the trend of data which is currently present. But in the case of data analytics, it deals with the trend on how the data will go ahead in the future. So you are going to predict the future, and you are going to be the fortune teller of data, right? So now we are going to see about how we can incorporate data science with Internet of Things. So here we have the life cycle for data science in IoT. Firstly, we get inspired from the maker mindset, and we have to use the sensors to generate the data, and we make a prototype or whatever it is. Using this prototype, we collect the data. It can be some structured data or unstructured data. Unstructured data means we need to go for some JSON or some kind of XML or something like that. And by using all these data, we have to monitor. Firstly, we need to create a SCADA system. This SCADA system will create a monitor, like it keeps telling like what is the trend now, what kind of data is observed, and then we need to ingest this data and analyze this data. This is the part where we have the advanced data scientists come into the phase. So now you may ask, like, what is the difference between the job of data scientist and the normal software engineer? The normal software engineer can do only up to this monitoring, but we need a data scientist to ingest the data and then to analyze and then to produce some insights from the data. They need to use some statistics to create some interesting information to create this application to be useful for the some kind of output we actually need to produce. So this part is not possible by the traditional software engineers, but data scientists, being proficient in programming and having a sound knowledge in statistics and incorporating these two coupled with the power of business knowledge, then we can convert these data into insights, and then it will be like a data driven decisions for your business. When you use these IoT based devices for this kind of task, IoT gets more value added. When you go for IoT based solutions by many corporates, you take anyone like any electronic IoT based solution providers, they all have some kind of monitoring system, but nobody have any kind of decision making system. Now the trend is changing and many are trying to make it. For example, when you see the Garmin watches, It will measure your heart rate, and it will measure the steps, and it will measure the temperature and everything. And finally, after your workout, it will say how many hours you need to take rest in order to make your body fit enough for the next workout. So something like that is happening right now, but this is not enough, and we need more IoT devices to be data driven, and it should make the decisions perfectly and even more. So the basics of Internet of Things, we have the operational technology, which has the things, which has the sensors and so many other equipments. So these are connected to the internet through the gateway, and then this data is broadcast through the networks using the public clouds and stored in the data centers. And from these public clouds and data centers, we create the analytics. Just mind the word analytics, it's not analysis. So there are two kinds of technologies: operation technology and information technology. The operational technology is where we collect the data, and the information technology is where we actually analyze the data and produce the insights. So this is the split of Internet of Things as a basic fundamental level. So we have a lot of sensors. Like here I present the various types of sensors which are available, and what are the parameters we can measure using the sensors. Right from chemicals, we can measure the electric or magnetic shock, or we can measure the optical light, or the velocity, or the temperature, or the humidity. We have a wide range of sensors available. Using these sensors connected to a microcontroller like Arduino, or a microprocessor like a Raspberry Pi, or you can use some neural network sticks, or some kind of Jetson Nano, which can be used for deep learning. So a lot many options are available for creating this data analytics. And the adoption of IoT in the current situation, we have like this. We have the wearables for the connected transportation, connected homes and buildings, and then we have connected cities and industrial internet. So today I'm going to explain about smart agriculture, how we can improvise the agricultural system using this kind of IoT devices. You can see in this screen, like we measure the temperature, humidity, and then we manipulate the data for, we have some analytics. So we work with the data, not just looking at the crops like the naive knowledge of a farmer. We actually provide solutions for the farmer to make him feel like he can gain confidence, and he can make more produce, and he can avoid some kind of losses by using this kind of data. So he cannot understand data, but you can. So you can create some kind of data analytics using this kind of solutions, so to minimize the usage of water, and then to decrease the wastage of investments. So these are the things which the smart agriculture can address to. The main focus is on the data. We actually use the sensors to collect the data using the IoT devices, and it has a magnitude of data. It can be like a huge corpus of data. This huge corpus of data is actually used to actually, like, we can analyze this data, and we can write some program using some statistical analysis or some statistical methods. Then that data will give you some kind of future analytics. So this is the magnitude of data which we are supposed to have by the end of the year 2030. That is 10 years from now. We'll have like 20 billion smart home devices, and 800 zettabytes of data will be generated by IoT devices. It's just by IoT devices alone. I don't include about the internet information like the social network and other media. And then we have like a $14 trillion business to be impacted by IoT in the global economy. So this is the huge magnitude which you need to understand the scope of IoT in the next 1 decade, or even more. So when we adopt this IoT, we have like data privacy issues, like we have like uncertainty, and then protection worries, present day workflows, and then high fee of implementation, loss of business technologies to steer the IoT software, not sufficient information about the available solution, too much media interest is on informational technology. So these are the barriers which we have, and these are the research problems which are available for the research scholars to address in the case of IoT research. So if you are able to come out with a solution that will really help for the IoT development community to move further and steer the developments in a faster phase. So then we have like the 3S of IoT, that is sellability, sustainability, and scalability. So these are the three main factors when you need to think about the development of IoT devices. Firstly, we need to see how you can sell this product to the market, and then how it is sustainable, like how it makes this entire system dependent on its own and not dependent on other systems. And scalability, this is the main factor, because we may think that IoT is some small device which is sending some data, but in a huge enterprise system or like in a huge farm, we need to have more number of sensors and more number of IoT devices. So these will definitely have a scalability issue. So for that, we need to work on to give some solution. Like scalability means it's like we have too many servers, a limited amount of server requests, and too many clients looking for data. So all these clients at the same time they access the server, and the server won't be able to respond. So for that, we need to find a solution in the case of IoT based data systems. And now I'm going to explain about a case study with the PM 2.5. PM 2.5 stands for particulate matter 2.5, the carbon particles of size equal or less than 2.5 microns. So this is one major problem which is happening in the Asian countries, be it India or China or even the Southeast Asian countries like Thailand or Malaysia or Indonesia. We are having a huge problem when it comes to the smog during the months of December or January. So that's a huge, it creates a lot of health hazards because it mixes with the fog, and then it creates a lot of traffic issues, and it affects the economy, and it affects the health. It can mix into blood, and it is not that easy to excrete. So these are the problems which this PM 2.5, when it goes inside the lung, can affect. So the magnitude of PM 2.5 we can compare with the sand grain from the beach and the human hair, and then the PM10 and PM 2.5 particle. So this is how we can see uh, the relativity of sizes, and we can see how sharp this PM 2.5 particles look like when it is seen through a scanning electron microscope. So here we have the sources. And then we see like it is very sharp, like it can even create some kind of ruptures on the walls of the lung lining, and it is hazardous for health. And this is the mortality map for Thailand. Most of the lung diseases are happening due to this PM 2.5 emission, and it is even higher than HIV, or even something like liver cancer or something like that. So this kind of lung diseases are related to this PM 2.5. So I have taken the data sources from PM 2.5 data of Berkeley Earth, and then we have a local database called Air for Thai, and other weather parameters from one school which has a weather station. The timestamp taken was from the period of 4 years, 2016 to 2019. So this is the magnitude of data which is collected from various provinces all around Thailand. We have taken Bangkok in the central region, and we have taken from all the 4 directions, from north, east, west, and south end of the country. And then the trend over the years is analyzed, and then this trend is uh, observed using this kind of IoT device which I have done. So this is a connection given from a Raspberry Pi and some PM 2.5 sensors, and this sensor device is used for collecting PM 2.5 data apart from this Berkeley Earth or F4 So here we see like we have like the Berkeley Earth gives only the PM 2.5 data, and the weather data comes from another API. So there is an irrelevant it's not actually irrelevant. It's like a kind of different location for different parameters. So I unified the approach by using this IoT device, and using this IoT device, I got the intranet system which gives this kind of data monitoring system. From this monitoring system, I was able to measure PM 2.5, PM10, humidity, temperature, carbon monoxide, and then it gave the insights for various buildings in my university. And the mist sprayers are used to spray when the PM 2.5 particles are more, so that will arrest the PM 2.5 particles, and it will decrease the humidity, and so it will affect the pollution to go down. So how we can implement machine learning in this PM 2.5 data? The data which is collected here, we have analyzed using linear regression and found the importance of feature using the F score. And we have used the unified approach, and then we have used the support vector regression. And this is the improvement of feature importance. The important features are found using this method. So this gave a refined set of features. From this feature, I was able to predict the progression of PM 2.5 over the future days. So then, if you want to have the source code for this particular project, you can read the paper which is given in this GitHub profile, and you can have the source code from this link as well. So these are the references. And I have a MOOC course on data science. If you want to learn data science, it is a completely free course. You can take it from this link, and then you can get to know more about data science, and simultaneously you can learn about the IoT devices. And I have my YouTube channel where you can have my lecture videos stored, so you can get all my video lectures which are available online. It's entirely free. And thank you so much. And I hope you have got some good information from me in this particular keynote speech. Thank you.